Hey everyone, thanks for tuning into the METUS Tech Show. On today's episode, we're going to talk about scroll compressors and why they fail. But first, it's time for the METUS Minute. Today's METUS Minute is on superheat and subcooling. Take it away, Bryn.
Thanks, Paul. So in all of our systems, superheat and subcooling are important measures for how the system is performing. In fact, many of our systems use a refrigerant saturation temperature to drive the operation of our compressor. Saturation temperature is defined as the temperature of the refrigerant where the refrigerant can exist in two states, both liquid and gas. As we change the pressure of the refrigerant, we're also going to change the saturation temperature. This is where the PT chart comes into play. A PT chart will show your saturation temperature for a given pressure in the system. So how does this relate to superheat or subcooling? Well, if a refrigerant has a saturation temperature of 100 degrees at 318 psi, like 410A, all we have to do is check the actual temperature of the refrigerant to determine whether that refrigerant is superheated or subcooled. Any temperature above 100 degrees indicates that the refrigerant is superheated or a gas. Any temperature below that 100 degrees would be subcooled or a liquid. Thanks for listening to today's METUS Minute. Now let's start the show.
The METUS Tech Show.
Welcome to the METUS Tech Show, a show for HVAC professionals by HVAC professionals.
I like how you guys bounce back and forth between heat pump talk and food talk.
The METUS Tech Show.
Mitsubishi.
All right, so I just found this recipe online, and my wife actually found it, and she said it was a viral garlic bread recipe, so I had to try it.
Is this TikTok?
No, it was actually YouTube.
Nice.
Right? So the first thing you do is you take a couple of heads of garlic, like the whole, I don't know if it's called a head or a bulb, but the whole thing of garlic, and you cut off the top, and you pour a bunch of olive oil in it, and you wrap it in aluminum foil. You do the same thing with shallots. Take a couple of shallots, you peel them, put some olive oil on it, wrap it in aluminum foil, you put it in the oven for about an hour. When it cools off, that garlic is nice and sweet. It's just soft. You squeeze it all out. You mash up the shallots. You put a stick of soft butter in there, softened butter, and you just mash it all around. The recipe called for miso paste, which I've never purchased or used or cooked with, so I left that out. But basically, this made a spread. I got an Italian bread. I cut it in half. I spread this on there. Then I grated some Parmesan and some Gruyere cheese and loaded the top of this with the cheese. I baked it, turned on the broiler for a few minutes afterwards to get that color on top of the cheese. Yeah. It was nice and bubbling. It was a hit.
Yeah.
It was a hit. It was probably the best garlic bread I've ever made.
Yeah. Yeah, I haven't had bread in about 3 months.
What?
My life has just been terrible.
Yeah, so if you're wondering why Steve is talking so slow.
Yeah.
That's why.
Yeah, it's depressing. I'm trying to do the no carb, no pasta, rice, bread, and all that stuff. So that really bummed me out. You're talking about garlic bread. It sounds delicious.
It was awesome. It was just great. Now, I don't know what the miso paste, I've had miso soup. I don't know what the miso paste tastes like. I don't know what it would have done to it. But I got to tell you, there's a reason this went viral. It was so good.
Yeah. Have you ever just roasted garlic to put on like steak or anything?
Yeah.
Because that alone.
Oh, yeah.
I've used like roasted garlic when it turns into that paste and it's sweet. I've just used that as the sauce on my steak.
I got my garlic masher too. So I'll use a garlic masher and that basically purees it and done it that way. But there's nothing beats roasting garlic.
Yeah.
And you can roast a whole bulb.
Yeah.
Like you said, and yeah, it comes out amazing.
It was delicious. It was the best garlic bread I've ever had.
Have you ever made your own bread? You might have talked about this before.
Yeah, I do it every Thanksgiving.
All right.
I make my own bread from scratch. I basically just make a quick bread, so there's no like type. It's not like sourdough or anything like that. But I just use bread flour, let it rise for a couple hours, and just go through the process. And then at the end, before I bake it, I'll season it however I want. So I'll put typically like oregano, rosemary, tons of garlic and everything. And it's just like a nice loaf. You can cut slices, good with butter. It's like a rustic bread.
Have you done a class in Houston yet?
Yes.
Yeah. So Maria gets these kolaches, I think they're called.
Okay.
Did you have those?
No.
It's basically bread with sausage inside already. It's wicked good. I remember the first time I went there, I could never think of the name kolache. I was calling them wicked good chalupas. By the time I finished, the whole class from Texas was calling it wicked good chalupas because I couldn't remember.
Wicked good.
Kolaches.
Yeah.
They're wicked good.
Yeah.
I love bread. How can you not eat bread? How can you be Portuguese and not eat bread?
Well, I'm trying to, bread makes me bloated. Trying to watch my figure, and
Round is a shape. I don't think you have anything to worry about.
Yeah. I had a funny story about making bread.
Oh, hold on. Let's cue the story music. Go ahead.
So my wife bought me a bread maker, all right, and it wasn't the most expensive brand bread maker.
Sure.
It was kind of a plastic piece of junk.
Hamilton Beach, actually.
But whatever. You put the flour and the water in, and I just couldn't figure out how this thing just makes the dough and then rolls it all out and bakes it at the same time.
Yeah.
But whatever. I threw all the ingredients in, and I turned this thing on, and it starts moving, and it's going. Puff of smoke. That was the extent of the bread making.
So
I'm
what
not
happened?
even kidding.
Well, the bread turned out phenomenal.
It started making this dough and it just smoked. It was terrible. So we threw it out. And then I tried making bread from scratch.
Yeah.
And I could not believe, I thought I was going to mess it up. I could not believe how good it came out.
Yeah.
So good.
It wasn't that hard. I think that the worst part is waiting
Yes.
for the yeast and all of that to work and all that. And I remember my mom making it, way back in the day, and she would throw a towel over the bowl and it would rise overnight, and she'd make the loaves the next day. And I did that, and it came, I couldn't believe it.
It's great.
It was the best.
The best way to get it to rise is throw it in the oven and turn the light on in the oven. Just the heat from that bulb in the oven is enough to just keep it warm and let it rise. It's an hour and a half, 2 hours tops.
Yeah.
You're done.
Yeah, it's
A lot of times with those towels, they'll get them wet. So it's got that kind of steam.
Yeah.
Keeps the moisture. And one thing that I have messed up in the past making bread is if you overwork the dough, that initial knead before you let it rise, if you overwork it, you get this really dense
Can't
bread.
do that.
I've done that once. But if you kind of leave it a little bit more on the sticky side and then just let the yeast do its thing.
That's the secret.
Nice pockets. And
That's
it's
the
great.
secret to making a good pizza dough too. You can't can't beat it up too much. You just, once it's risen, you just spread it out and that's it. If you play with it too much and you roll it and knead it, then it turns tough. And now you got this.
We were just talking
plastic
about this
pizza.
last week in Georgia about making bread. And the funny thing is about when COVID hit, that's what everybody was doing. Everybody was baking bread at home. So everybody was locked down. So everybody was like, I had friends of mine like, I'm going to go make a good sourdough this weekend. I'm like, okay.
I got into hunting for COVID because there was too many times when I went to the grocery store and there was no meat on the shelves. And
What'd you hunt?
Deer.
We'll be right back.
Hey, listeners, if you like the METUS Tech Show, you should check out our YouTube channel called the METUS Training Network. That's METUS Training Network. Head on over to the METUS Training Network for tons of videos and programming made for HVAC professionals just like you. We've got technical training tips, HVAC program updates, and episodes of our new HVAC talk show called The Comfort Zone. Of course, you also get to catch up on more episodes of the METUS Tech Show as well. Head on over to YouTube and subscribe to the METUS Training Network today. Now, back to the METUS Tech Show. Yeah. I went hunting yesterday.
Geared up.
Hit a deer with my truck.
Yeah.
So I got to get that.
You got a good one. 6-pointer.
Hey, I told him, Brandy, this is like probably the 5th or 7th deer he's hit.
Yeah.
It's
in
the
his
second,
truck,
but my poor truck, I'll tell you. Going through that whole thing with insurance again and co-payments and all that. And
Fighter pilots, every time they shoot down an enemy plane, they put the flag of the enemy on the side. You got to get a couple of flags with some deer on the side in the driver's door.
Yeah, scratch some lines and some hash marks.
I was pulling in today. Barely noticed.
You didn't notice the big chunk of fur sticking out the front bumper of my truck?
You know what?
It's still in there.
I know.
And it's there not because I'm a sick man. It's there because I want to make sure that if it gets appraised, insurance sees the deer hair on there. They
You
can't
get that
say
adjuster out there.
If you hit enough deer and you save enough of that deer fur, you could probably make yourself a wig.
Yeah.
Or toupee.
Yeah.
You might have a head of hair
Yeah.
after that.
Nice.
Yeah, and get plugs
Scarf.
put in.
All right. Anyway, what are we going to talk about today?
We're going to talk about compressors and more, namely why they fail. So
That's a good one.
Sean from the Tiger team put together a really good presentation, really informative about compressors, why they fail, and the basic anatomy of that compressor and the importance of oil in the system.
All right,
So
so
we're going to break that down.
So this is a benefit of being on the training team. Faith from our team recorded that video of Sean doing that. And of course, I get to look at the videos and approve it and make sure it's good. And it was an awesome job. Sean and Faith both did a great job. And then I was sitting there watching this and go, this information is really good. So we're going to be posting that video on the LMS. We'll probably put it on the Training Network YouTube page, and who knows where else it's going to go. But I told Bubba, who manages the Tiger team, I said, we're going to do a podcast on this. We're totally going to plagiarize this video.
Oh, yeah. We're going to take credit for it.
Yeah, he's all for all. It was done by
Anything-
the training team.
Anything that Sean has to say, I'm listening.
Yeah.
Absolutely.
So
And that's the same thing Bubba said, right? If I'm having lunch, if I'm at a training class and I'm having lunch and Sean comes in and starts talking, I'm listening.
yeah,
The guy, is really wicked smart. So we're going to talk specifically scroll compressors, but the stuff we're going to talk about is going to kill any compressor. I don't care if it's a scroll or reciprocating,
Or rotary,
rotary. It doesn't matter. Right. So, Brent, let's start with the anatomy of a scroll compressor.
Sure. Yeah. So breaking down the compressor into essentially there's three main parts. At the bottom of our compressor is where the pump is. It's where the oil would sit typically inside that compressor. At the very bottom is the pump, and then the main bottom bearing. So the oil is used to lubricate these metal components, reduce friction, right? So we've got all these metal parts inside there. There's very, very low clearances between them. Without oil, we build that friction because it's a metal-on-metal contact, and that can cause all kinds of problems. So when we go from that main bottom bearing, that oil is going to travel up through oil galleys into the main section of the compressor through what they call the rotor channel. The oil lubricates the bottom main bearing and the orbital sections at the top of the compressor. At the very top is our scroll section, comprised of a fixed and a rotating scroll. The rotating scroll works by increasing pressure. So as that rotating scroll is rotating along that fixed scroll, we're actually passing or increasing the pressure of that vapor, right? As we go through those channels get more and more narrow,
Squeezing
increasing the pressure. And then right at the center of that scroll is our discharge pipe. So at the highest pressure of that, rotary scroll or that rotating scroll, we discharge that hot gas.
excellent. Well done.
Yeah, and above that scroll, and there's just a couple of reed valves there that one thing they do is just prevent it. But that has nothing to do with compression. It doesn't really matter.
You got it.
So you mentioned oil, and the only place, I keep telling people this, the only place in the system you need oil is in the compressor. It doesn't have to go anywhere else. And we just need it there for what you said. If it was metal on metal, same thing. It's the only reason your car engine needs oil is because we have metal on metal and it needs that to be lubricated to prevent damage.
Yeah.
All right. So let's talk about the oil. All right. And there's several things we could talk about when it comes to oil. So let's just pick one at a time.
Yeah. So let's start with oil starvation. So that's one of the biggest factors to a compressor failure, right? One of the biggest, oil starvation. So too much oil is leaving the compressor, not enough is coming back. Now, we have high velocity refrigerant through our system. Some oil will leave the compressor. Ideally, not much, right? We try to maintain most of that oil. But the reality is some refrigerant may carry some of that oil out. That's the potential, right? The problem is are we keeping it? Are we retaining it? And are we getting it back? So what causes us to have this oil starvation condition is things like poor piping practices, right? We've talked about this a million times, but if you're putting in oil traps, right? Some systems want oil traps. We do not, right? And because we don't want those oil traps, if you do decide to pipe them in there, you could actually be starving that compressor of that oil.
Good point.
Yeah, that's a good point. Our systems are engineered as they are to get their oil back. We don't have to add any traps. And Bryn, I was teaching a class today and you happened to walk in. I think you walked in right when we were talking about a very hot topic in the residential world. Can I roll up line sets?
Yeah.
And it drives me crazy. Can I roll them up and set them up vertically? Can I roll them up and put them horizontally?
Yeah.
Don't roll up line sets to get that extra pipe. And this was a topic that came up because of the 16-foot minimum recommendation, right? We don't have to use a 16-foot minimum, but we're doing this to prevent noise. So a lot of contractors would be tempted to roll up that line set. And to me, that's creating a giant oil trap.
Yeah.
And I know this firsthand from experience. I was on a job site with rolled up line sets that were strapped to the customer's house. And he even painted over the line sets to match his house. All right. And I ended up cutting these out and just flaring it and connecting it directly to the unit. But the weight of those coils, it made my hand drop when I grabbed it and cut that coil out. The weight that was inside of that coil of pipe, of all the oil that was in there. And this guy's grass around his units were about 2 feet high. He hadn't cut his grass in a while. And I noticed rusted compressors all around his unit.
They weren't getting oil.
So they was just changing compressors over the years. Probably didn't know why he was burning out compressors. And I noticed in the pressures on the gauges. My high side would be very high, and I'd almost be pulling into a suction.
Yeah.
The system was charged correctly, but we were creating a big oil trap and a restriction. So don't coil up your line sets with Mitsubishi equipment.
If somebody told me a long time ago when I first got into this business, if a compressor dies and you replace it and you don't know what killed that compressor, guess what? The second compressor is going to die. So you have to know why it died. Yeah. And the oil starvation is a big one. You know, that oil is not coming back for whatever reason. There was a job we had on the West Coast where they had a couple of compressor failures. And I wasn't there, but I saw the pictures that were sent back. So, I think it was the second or third compressor that said something's not adding up here. So they took out the compressor and they took out the receiver. And the receiver has screens in it, the filters in there, the screens rather, the strainers. And they cut it open, and there was like this stuff, I don't know how to describe it. It looked like chewing gum almost. Wow. And they figured it was that stop leak stuff, that additive. Yeah. I'm sorry. I know some people are selling it. They sell it in supply houses. But in my opinion, no one should ever put that crap in any refrigeration equipment ever. Because you can find a leak without it. So what that stuff does is it goes through the system, and when it finds a leak and there's air, it hardens. And that hardened in that strainer, made it back to that strainer. No oil was going to the compressor. The compressor died. They changed it out. They didn't find out why it died. The second one died. And guess what? You can replace compressors there once a week. They're all going to die unless you figure out why. Yep. So oil starvation's a good one.
Yeah. I always say there's two different types of traps. Oil traps that you can put in the piping. Some are on purpose and some are accidental. Yeah. Right. So the other thing is just pay attention to piping practices as you go along and make sure, like I know, Steve, when I did come into your class, you were mentioning what happens when we try to go under a beam, right? You're running line set across the ceiling. You got to get under a beam. How do I avoid making that refrigerant piping a trap? Right. So we want to make sure that our vertical drop is half of the horizontal run before we come back up. That allows us to eliminate the potential for an oil trap. So proper piping practices, right? Sometimes they're accidental, sometimes they're done on purpose. Regardless, we never want them.
Yeah, and one more thing. When we say there's no traps, we're also assuming that you're not exceeding the refrigerant line length.
Exactly.
So don't put traps in there and don't exceed the refrigerant line length. Don't go over by 10 feet. Don't do it. That's another thing that's going to cause oil starvation.
Yeah. So typically when we have that oil starvation condition, how does it manifest in that compressor? Is typically on the top portion of that compressor, because remember the oil sits in the bottom, third or so of that compressor, and the job of that oil is to travel upwards towards that rotary scroll at the top, lubricating all the metal to metal contacts or components within the compressor. So typically when we're oil starved, there's not enough oil to travel up the shaft of that compressor. We get to the bearings at the rotary scroll. That's where we start to get that metal on metal contact. We start kicking metal shavings loose. We run into problems.
Yep.
You might even actually seize the compressor at that point.
You could. And the next one we're going to talk about is oil dilution. Bryn, what do we mean by oil dilution?
So oil dilution just means that refrigerant has become entrained in the oil, and it lowers the viscosity of that oil. So we need enough viscosity is resistance to flow, right? So we need enough of that thickness to that oil for it to actually adhere and for it to actually be able to travel. When refrigerant gets trapped inside that oil from situations like an overcharge, it thins out the oil. It's not going to lubricate as well.
And that's another reason why we want to make sure, especially in cold weather, when you energize a piece of equipment, you let it energize for at least 12 hours before you turn that on, because you want to get that crankcase nice and warm. So any oil that's in there, first of all, it's going to thin out a little bit, and it's not going to thin up. It's not going to have that liquid on top of it just sitting there. We want that liquid to boil off. We want nothing in there, but oil and vapor.
Right. Yeah. So letting that system preheat for 12 hours, we send wattage to the compressor. Some may have crankcase style, but at the end of the day, we need to boil off any liquid refrigerant that may be left inside the compressor on initial startup.
Yeah. So that brings us to oil contamination.
Yeah. So
and we just talked about this again, another topic we talked about in class, being organized with your service fan. Now, I was a slob in my service fan, but one thing I did, I'm going to be honest, but one thing I did watch out for is I had a set of gauges for each refrigerant and each type of oil that I was working with.
Me too.
Because the worst thing you can do to a POE system is take a set of gauges that are filled with mineral oil and dump it in accidentally into another system.
Yep.
They don't mix. All right. And they'll actually make a waxy substance. And what happens to our strainers? We plug our strainers.
Oh, yeah.
So a lot of contamination is happening due to human error. And it's after the fact, after the system's been installed, and it was installed clean, tight, and dry, but someone came along with a set of gauges and contaminated it.
Yeah, but we've also seen a lot of issues where it's poor piping practices. So I was talking to Bubba a few hours ago, and I have I'm fortunate enough to have started with this company when Bubba was still teaching classes when I first started. And I sat in his city multi class. And when I was teaching, I used to call it Bubba's rules. Keep it tight, keep it clean, and keep up with your line length. So tight and clean is self-explanatory. In line lengths, you're installing a city multi job. You're going to run some lines. You need to do an as-built, an accurate as-built. What were the actual measurements, the distances of lead line, the risers, and how many elbows? Yep. And what he said is put a tag on the end of that line when you run it in the mechanical room, especially if you're not making the final connection, or even if you are, and write on there how long it was, what's on the other end of that line, all the information someone's going to need to do the as-built. They're just going to save you time. The hardest part, or not the hardest part, but what takes the longest when doing an as-built is gathering the information. So you just made life easier for you or whoever's going to do that as-built. But proper piping practices, and we've talked this when we did an episode on it. Yeah. We see line sets with just a piece of electrical tape on them. They're open to the atmosphere. We have found gravel and sand, and metal shavings, copper shavings inside. I think, some people are taking Sawzall and cutting lines and letting that debris, or the deburring, they're deburring the end of the pipe, and they're letting all those shavings get back in there. That's going to destroy a compressor in no time.
Oh, yeah. Yeah, and that's the thing is that, oil contamination isn't just from, dissimilar oils, but it can also be from poor piping practices. Any of those, emery cloth, any oxides that make it inside the piping will eventually make their way back to the compressor. Now, we have strainers all over our equipment, right? There's strainers at the indoor unit. There's strainers at the branch controller. There's strainers at the branch box. There's strainers at the outdoor unit. There's strainers everywhere. But what happens is we have this really high velocity refrigerant. And so those metal shavings are traveling through the system, getting knocked around, banged around, and they break into smaller and smaller parts. So we have 50 mesh strainers. We have 100 mesh strainers. Well, if those particles break off into pieces that are smaller than those strainers openings are, they're going to find their way through. And when they do, they make it back to the compressor. Now, the clearances between our bearings and, different components of that compressor are much more narrow than the mesh strainers. So they may make it through a strainer, but they're not going to make it through those clearances. They start to wear away at the metal components. We get that metal on metal contact. We start to run into those problems.
Yeah, and I didn't realize this until I watched Sean's video, but inside the compressor at that base, there's a magnet there.
Yeah.
And there's a magnet there to collect any metal debris that may get in there.
Sure.
But it can only collect so much before the metal, it won't stick anymore. You
Right.
know, it just got so, but we found stuff like, sawdust and sheetrock dust, and that stuff can be so fine. There's no strainer in the world that's going to stop that.
Yeah, right.
And once it gets in there into the windings, it can cause a problem. And metal shavings, if they get into the terminals, the terminals on the outside where you put UV and W, just inside that compressor, if they make an arc, if they make a connection across one of the terminals, that can get blown out. And I've actually seen terminals blow out in a compressor where the whole charge is gone.
Yeah.
Now, see you later. Bye-bye.
Yeah. I've seen pictures of people walking up and that whole UVW terminal is gone.
Yeah.
And it's just open to the compressor that blew right out due to a short across those terminals. But yeah, I mean, those terminals do have to enter into that compressor. So you got metal shavings that continue to lay over those terminals. They'll eventually make it their way through that insulation, and they'll start to cause those shorts.
And thinking about the oil again, going back to the oil, I remember one time it was a unitary product. It was it had a filter dryer in it, and the pressures looked like there was a restriction in there. And I ended up pumping it down, and I cut out the filter dryer, and it was sludge. It looked like molasses.
Wow.
Was inside the refrigerant line. So you guys are pretty smart. What could have caused that?
Moisture.
Yes. Water. Right?
Non-condensables. Non-condensables. Right. You don't pull a proper evacuation and get non-condensables. What's going to happen to the temperature?
Yeah.
Right. It's going to be screaming that oil. Now you're burning the oil. And that oil was just a sludge. It was horrible. How that compressor was still running? Actually, I don't know how that compressor was still running.
Yeah.
But but non-condensables, of course, it goes back to. I think proper evacuation goes back to good piping practices. A triple evacuation, get a micron gauge. If you don't have a micron gauge, you have no business touching a piece of refrigeration or
at least not installing
equipment.
it. Yeah.
Not installing it. No, you have no business doing that. So get that. And there are other things that can kill a compressor. What are some of the electrical things that can happen with your power supply that's going to?
Yeah, that's the big one, right? So power supply itself. So improper voltage through those compressors can cause some issues. What we actually find is typically with the higher voltage units or 460 units, by the time we make it to our diode stack, which is converting to that high voltage DC for our inverter, we're at like 600, 700 volts DC. Now, even though we are passing through those IGBTs and making a simulated three-phase AC voltage, it has the characteristics of DC. It still wants to find ground like a DC voltage would. And so what we find is a contaminated system with metal shavings in the oil. Those larger voltage compressors are more apt to short to ground on those windings because of the fact that it's got that higher voltage DC passing through those windings.
That's true.
Now you can still do it with low voltage, but
yeah.
More common with the higher voltage just because of what, the characteristics of DC voltage.
Yeah, I've seen brownouts fry a compressor.
Sure.
That can happen. I've seen that happen.
Yeah. So even, Sean makes a great point, which is sometimes you'll have an electrical failure of that compressor where you'll ohm it out to ground and you'll find those shorts. Yeah. It didn't come from some sort of failure of the compressor. It could be oil contamination. Right, oil contamination can start to attack the windings of that compressor, strip away the insulation,
that varnish, and
that's when you get your short. So even a electrical short could be caused by poor piping practices. Not taking care of that system, keeping it clean, tight, and dry.
Yeah, and again, I can't say this enough. Good piping principles and practices. When we see multiple compressor failures on multiple units and they're all on the same roof, chances are somebody wasn't doing their job properly. They weren't following good piping practices.
Yeah. And, like you said, I always tell people in class, Mitsubishi compressors don't die, they get murdered. Yeah. So you have to find the murderer. It's like playing Clue. You can't just swap out a compressor that you have without a doubt diagnosed as seized or, a problem. You got to figure out, how did it happen? How did we get this compressor to this state? If you just swap it out, you'll be probably swapping it out again. Right. And it means you're not doing your job as a technician. You got to figure out what happened.
Exactly.
Track the source.
All right. So, Brandon, we talked about varnish on the wiring, on the windings, starting to wear down.
Yeah.
Right. Can I see this with a meter?
Yeah.
Right. I can see it with a megometer. So Mitsubishi recommends megging that compressor with a 500 volt setting. And we should be seeing over 1 million ohms on our compressors.
Right.
Right. And that's basically across the board. Now, we need to take caution on when we do this, right? Because temperature of that component, of any components in our outdoor units or indoor units, the resistance should be checked within a certain temperature.
Right.
Right. So that goes especially for compressors. The cold day out, let's say it's 20 degrees outside and I need to meg my compressor. Not a good idea to do it in that temperature. So I need to bring the temperature of that compressor up.
Yeah.
Now, what are we going to do at that point, right? We're going to get crafty. We're going to have to put a heat lamp on that compressor. You're not going to unbraze the compressor, remove it, and take it inside the house. It's just not going to happen. Yeah. So possibly a heat lamp.
They make heat blankets now, I've heard. Yeah. I haven't been in a van since that. I guess it's like a really common thing now, these heat
There's so many
blankets and
tools
stuff.
out there now, and we may be missing some of them. But basically, you got to bring that compressor up to a reasonable temperature. And those temperatures are listed in the service manual for when we're checking resistance across windings. But not only that, resistance from winding to ground. Right. And there are a ton of tools out there for that. And again, can't stress it enough. Make sure you check it. You remember Sean Gallagher used to come in with a compressor under his arm?
When he was a DSG and he taught the class, he would start the day with putting a compressor in our freezer, right? And it was sealed. He'd put it in the freezer. And at the end of the second day, he would take it out and have people ohm it out, and it would show that it's shorted, and it was just cold oil.
Right.
Yeah. That's all it was.
The liquid acts as a conductor, and you might see these shorts. Now, it's important to note, right? If you're checking for shorts across windings, you don't need a megger for that.
No.
Right? If we're checking for shorts across windings, your meter should be fine. We're not looking for much resistance there, right? So we can handle it. It's when we're checking for shorts to ground, that's when we want to use the megometer. We're going to find a nice ground on the copper piping, right? So just make sure you're using the right tool for the right test as well.
You guys threw me off when you said megometer because for 30 years I've only heard megger. The proper name is hardly used.
We had someone in class called it a megometer today. I was like,
look
at that.
That works. Yeah, that's fine.
Yeah.
It's a megger.
But and then we talked about contamination. I just wanted to, but what is everybody doing out in the field to protect the piping? Are we just throwing some electrical tape on it and calling it a day?
I hope not.
Please don't.
No, I used to work with a fantastic gentleman at the hospital. He would drive me nuts at times because he was very precise with things. But one thing he would do at the end of a job when we weren't finished piping is he would braze the end shut.
Yes.
Yeah.
And he was adamant about it. I'm brazing the end shut. You have to do it.
I would if it was hard drawn pipe or hard drawn ACR, I would smash the end of it down with a hammer. I'd flatten it with whatever I could, and I would braze it because nothing is getting in. You have to do that. It's not tape is not good enough. You buy if it's soft drawn and you buy it in a roll, it's got a plastic or a rubber plug in it. Yep. Right, and we could go on about how those get left in the system or anything else. But until you have to cut it, leave that in its place until you have to connect it. And if you have to leave it, if you're not going to finalize this piping, if you're not going to leave it under pressure, if you don't know that it's sealed tight, then seal it up. Yeah, nothing is worse because. Not that this is related, but I remember the FBI office is a couple exits down the road, and nobody knew it was there. And they had an old train heat pump. Those Weathertrons, those things were beasts. They would last forever. But so it was no heating. It was no air conditioning because it was around May or June. It was just starting to get warm. And I go out there, and the reversing valve. At the bottom of the reversing valve, the common suction that goes from the reversing valve to the compressor snapped right off, and it was facing upwards. It had been running like this all winter. Those climate-tough compressors, they were tough to kill. It had algae inside the pipe, right? So this was an R22 piece of equipment. You can't get R22 in anymore, and you couldn't just replace the outdoor unit. Now you got to replace the indoor unit. Now the ductwork is inadequate, so we had to get them by. So I remember I fixed that. Somehow I got that pipe back on. I think I silver soldered it on there and put a vacuum pump on there. And I used to drive by there because it's on my way between the home and in the office. I'd buy there twice a day. We sent our shop guy in there in the middle of the day, and we were just swapping out the vacuum pumps with fresh oil
Wow.
And the compressor, I couldn't get it below 1,500 microns, I think. There's no way.
Yeah.
Everything was
That
so
point.
full of water. But we had to get them going. It's the FBI. And we had to get them going until we could get there and replace the equipment, which is not going to happen in a day or two. So they really needed the heat.
Yeah.
Those are the same guys that drew guns on me. On a different call. This was right after September 11th. And I was in the basement doing some maintenance on one of the furnaces. And I had keys to the building, I had access to the whole building. There's multiple tenants in there. It was a commercial building. And these guys come down the stairs, and I'm sitting there with a screwdriver or nut driver in my hand. I forget what it was. And these guys come down, and they aim these Berettas at me. He goes, "Let me see your hands." Whatever was in my hands, I just dropped.
Yeah.
And I go, "Here are my hands." So then we had to get security clearances. And it was, I hope I didn't just divulge national security information.
No, hopefully not.
All righty then. So I think we covered it pretty well.
Keep it tight and keep it clean. Please keep it tight and keep it clean. That's the important thing.
Yeah.
If you install it properly, it's going to last a long, long, long time without any issues.
So last night, because we were on the topic of bread, I made calzones
I love
from
calzones.
scratch. Did chicken bacon ranch calzones.
Ooh.
So good.
Yeah.
I
So
don't.
good.
I don't like chicken bacon ranch pizza.
You know what? I'm not that big on it either, but it wasn't just cooking for me. So sometimes
So
you
I
gotta
just
suck
found.
it up.
I'm sorry.
Oh, you're good.
I'm sorry. I just totally. It's so rude. Sorry.
This is going to be an onion story.
It is. So I just found a new onion recipe. So, hear me out. French onion meatloaf.
Oh, it really is an onion.
I thought you were kidding.
Fresh onion
I'm not
meatloaf.
kidding.
Okay.
I just told my wife about this. French onion meatloaf with mozzarella melted over the top of it.
Do you put breadcrumbs in your meatloaf?
Yeah,
I thought you can't have bread.
sometimes.
Well,
I haven't had meatloaf in probably 3 months as well.
Oh,
Meatloaf, we don't have it that often, but I saw this recipe for French onion meatloaf.
Wow.
Yeah.
Yeah.
So I think
That sounds right up your alley.
Yeah.
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 That should
So-
be good.
I listened to that podcast when you were talking about your French onion, whatever it was called,
Chicken.
French onion
chicken. You know what? And I got so sick of hearing the word onion. I was like, "What? We're never going to talk about this again."
Once you have it, change your life.
I almost made it the other night. I think it was last week, actually. I was like, yeah, maybe I'll just stop at the store and just grab like the ingredients because I already have the Lipton soup mix. So I'd really just had to get like some shallots and some onions. And then again, not cooking alone. Person I'm eating with doesn't like onions. So that was out.
Oh, okay.
Yeah.
Also, so alternatives for breadcrumbs. And this is going to sound weird, but I have in the
Protein
past-
powder.
No. I have used pork rinds. So chicharrones, right? Because they're crunchy already. So you put them in a bag and you crush them up, and it gives you that holding like a breadcrumb, but it keeps you from consuming bread.
Interesting.
Sounds like a heart attack.
I've actually breaded chicken with it. Like had whatever you call it, pork rind chicken. Pretty good.
Okay.
All right. See you in the next one.